I'll keep the bag.
All right, thanks for sticking with us. This is going to be the final session of the day. We're running pretty much on time. This is called Designing Decentralization, Fireside Chat with Stellar co-founder David Mazières. David, are you ready? How are you?
Good.
Good. Welcome to the Builder's Bridge.
Yeah, it was great. It was great hearing about Stellar Beat. That was really a moment when, because I'd conceived of these, quorum slices and stuff, and then to have someone else go and build a website where I could actually visualize it, it was so cool.
Yeah, I got to say, when I look at Stellar Beat, it takes something that's incredibly, well, maybe not incredibly, it feels like abstract, like mathematical sets or something. It turns it into a graphic visualization, and it definitely makes it a lot easier, and you can, it was really cool. I'm glad you got to see that. And I do want to talk about that. I want to talk about about the Stellar Consensus Protocol, about its origins, about how you designed it, about kind of like what it's like in there. But I think it'd be interesting to go back a little bit. Let's go back a little bit before, because you didn't start out thinking, oh, I really want to write a consensus protocol for a blockchain, right?
No, I started out thinking blockchain is crap and this cryptocurrency stuff is a scam, just a huge waste of energy. And then in 2014, Jed approached me and he said, well, I want to do this blockchain that's going to be multi-currency, right? And so I started, and he'd sort of done Ripple, which didn't, but Ripple's consensus algorithm had some problems. And so the idea of trying to do something where there's no proof of work or stake or anything, and where you could issue assets on the thing that would be worth many, many times the value of the native cryptocurrency was an extremely interesting problem for me. And it was kind of we talked in June and of 2014, and then whatever I was supposed to be doing at Stanford the next week, I found that all I was thinking about was this problem. I was like, wait a sec, this is it's hard enough and nobody else has done it, but I think I can crack this problem. So I was like, well, why don't I just come full time and work on this for the summer.
What were you doing before? What were you supposed to be doing?
I don't even remember. I mean, whatever my normal research was at Stanford in 2014.
But you have a history thinking about peer-to-peer systems, right?
Yeah. So I would say one of my formative experiences, so I'm pretty old compared to most of the people in this room. So I went to college in the early 90s, and this was before SSH, right? Well, before the web was widely used too. And so in the early 90s, PhD students at Harvard didn't even have root privileges on their own workstations, right? And partly this was because everything was Ethernet thin wire, right? So you basically could snoop the Ethernet and see everybody's passwords because there was no SSH either. But so they were just locking this stuff down, and it drove me absolutely nuts that here are these super smart PhD students who are much smarter than the system administrators, but because security, they weren't allowed to innovate, right? They had a qualitatively different access to the systems, and particularly as an operating systems researcher, if you want to do OS research, you got to be root. You got to modify your kernel and be able to reboot. This didn't make any sense. So after I graduated, I spent a year. Well, after getting rejected for every PhD program I applied to, I got a job at Harvard, and I was brought in as a system administrator to kind of try to break this monopoly and set up a system where the students, more people could have root access to their machines. So I'd say that was a very formative experience. And then when I got to grad school, I started where I was really bothered by AFS, which was this global file system that should have been awesome, except on every client there was this file called user vice self-serve DB or something that listed all the servers that you could connect to, right? And only the system administrator could set that up. And I was like, well, that's imagine a web browser where there's a file that says all the websites you can go to. That's completely stupid, right? So that led me to build this for my dissertation, this decentralized file system that was both more secure than AFS, but more importantly, any client could connect to any server in the world. And it didn't even rely on certificate authorities because I was wait a sec, you have a file system which is secure, which is managing a file namespace. And guess what? We have this way of assigning one file name to another file name. It's called the symbolic link in Unix, if you're familiar with that. So why don't we use the file system itself for key management, and we'll make the public key part of the the sort of canonical path name of each server, but then you can like anybody else can assign names to servers by just creating symbolic links, and it was very intuitive compared to like if anyone's ever like used like OpenSSL to like create like a self-signed certificate or a certificate signing request, like a total mess, right? Whereas like symbolic links, like super easy to like create and remove symbolic links in the file system.
But the system that you're describing, like as you start to describe it, it actually, like it's here, blockchain is there. It doesn't feel like the distance is super great.
Yeah, so like a lot of these ideas, like a lot of the stuff I was doing, like we did this like read-only version of SFS called SFSRO, where basically there were only two RPCs. One was get me the signed root of the file system, and the other was here's a hash, give me the preimage, right? And so we took a normal file system, we replaced all the block pointers with cryptographic like collision-resistant hashes, and obviously that idea has like heavily inspired like a bunch of things now. Like if you follow what's happening with like Protocol Labs and like Filecoin and stuff.
And as you thought about this, like because I want to march forward in time a little bit after
Sure.
that, but the first thing I'm curious about is like underneath all of this, there's this sense of, I don't know what I'd call it, irritation or injustice.
Yeah.
What is it? What
It is that like
bothers you?
I cannot stand the idea that like people are like restricted from innovating because they don't have access to the same APIs, right? I mean, if you look at the design of Unix, right, there's like so many things that you can only do by being root, right? And like a particular example of the bad effects of this are that like Unix, it's got security, it's got like multiple user IDs and whatever. But like most applications can't make use of that because it's a big pain to like have to like create user IDs dynamically. And so you have a lot of applications like web servers say like doing their own access control with like htaccess files or whatever, and then they get it wrong, or they have like time of check to time of use race conditions or whatever. And then it's like we're like re-implementing security at a higher level on top of an API that sucks. It's like not very convenient to do things because it's got all these like race conditions and stuff. And so, yeah, so that kind of like, I mean, I guess we're still back in time, but then when I was in grad school, for example, I worked on this operating system called the exokernel, where the goal of the exokernel, which was articulated by my advisor and now colleague, but then fellow student Dawson Engler, was to create an operating system where there was protection but no abstraction in the kernel, right? So using like physical names for everything, and so the idea was then, like, as a programmer, it didn't matter if you were root or not. You had like whatever hardware capabilities, like as long as you could use them safely, you could use them. And typical operating system interfaces were implemented as an untrusted library on top of that weird exokernel interface, which meant that if you wanted to rewrite them, you could implement them a different way. You didn't need to be root to do that.
How did you interact with it? Did you just dispense with the traditional operating systems that people use?
Well, no, we wrote an operating system. So I wrote a kernel from scratch,
So in all of this, right, okay, there's this background that you have that sort of gives, and it's driven in part by this desire to have, to have smart people have access to what they need in order to innovate, right? And this leads you sort of been...
Which is the antithesis of the banking system, where it's like
okay.
you're either a bank or a customer, and if you don't like what your bank does, well, you can choose from maybe 10 other banks that also suck.
And that idea you articulated, which is like sort of the pattern mapping of what you thought about in file systems to the banking system.
Yeah.
Had you already thought that before 2014 when Jed approached you, or was it like starting as you turned your mind to... Which happened first? Did you start thinking about the applications of this to the banking system, or did you start thinking about consensus in blockchain? Do you remember?
Well, I mean, I guess both at the same time, right?
Okay.
Like, the idea of using blockchain for kind of real-world stuff, like not trying to replace the monetary policy or whatever. Because I'm a very uncynical person, right? So I believe that people aren't perfect or whatever, but probably most people who are working at central banks are trying to do the right thing and help the economy. And I doubt a bunch of engineers who think they're smart could necessarily do better than these PhD economists. So the idea that we could leverage this good stuff but like, make it so that everybody, whether you're Franklin Templeton or like an undergrad doing a research project, you like literally have the same APIs to program to. So you may not have the same assets, but you have the same level of access. That's just going to unleash all this innovation. And we've seen it so many times, right? Like, again, like, we were in 1994 or whatever, when like people started using the web or whatever, it was like you would wait for Netscape to like add a new feature, like credit cards or like whatever, like or whatever, underline text or I don't some new image format. And then they introduced LiveScript, which became JavaScript, and suddenly like you didn't have to wait for the people developing the browser to like come out with a new feature. You could like, as a web developer, you could like program the browser and this unleash huge amounts of innovation. Same thing with cell phones, right? You don't have to wait for Nokia to put some better alarm clock on your feature phone, right? You just go to the App Store, or like anyone can write an app, or you can program your own phone if you want.
I mean, I guess same thing with smart contracts.
Yeah, exactly.
I mean, it's interesting because just right before this, sitting here, Moots, Alex, and T-Dep Tommaso, like they don't work for Franklin Templeton, I don't
right.
think. But they can build whatever they want, right?
Exactly.
They have this access to innovation. I like it. Okay, back to the moment, right? So you've gotten into this time, it's 2014, you've been given this problem that you sort of have this inkling that you can solve.
Right.
And you can't even focus on the rest of your work.
Right.
Tell me what you can remember about working on it. What was the series of unlocks? How did you know you were on the right path?
Yeah, so I guess I started down a kind of false turn where I was thinking of like some kind of like epidemic consensus where like you couldn't like there was no way to like contradict yourself and sign a bad transaction or something. That turned out to be a dead end. But then I ended up kind of taking a lot of inspiration from the internet, right? Because the internet is this like decentralized global system, and it works. It's amazing. And one of the things that was not clear a priori was like we could have ended up with like an internet protocol like IPv4, IPv6, whatever, and then a bunch of different networks that all implemented IPv4 and IPv6. But that's not what we ended up with. We ended up with like this one thing that we all call the internet. And when I say the internet, I might think of the network that has like Amazon and Google and Stanford. You might think of some other sites that you care about, but it's like we all kind of agree on what it is, even though so if some ISP were to come and like offer IPv4 connectivity that didn't get to any of these sites, we'd be like, well, no, that's not the real internet, right? But the way the internet works, there's no like central authority saying like this network, you connect to that network and so on, right? It just is a kind of a bottom-up thing that's arisen out of these like pairwise relationships between ISPs. And there's kind of, two kinds of relationships. There's peering, where you have like two ISPs that just like agree to pass each other traffic for free. And then when you have a large ISP and a small ISP that wants to connect to it, then the small ISP has to pay the large ISP, and that's called buying transit. And the funny thing is, you don't need universal agreement on who is and is not a tier 1 ISP. Like occasionally, people engage in kind of brinkmanship about like, hey, you're not really a tier 1 ISP. How about you pay me for transit? And then occasionally people will call each other's bluff or whatever. But at the end, the problem like always resolves itself because there's such an insanely strong incentive to be connected to the rest of the world that it's just like it's not tenable to go off and say like, well, I don't agree with you. I'm going to go off and do my own internet, right? And so that the goal is to kind of like replicate that in the financial system and say like, okay, so we have this network, and like, sure, North Korea could fork Stellar and have their own version, and they don't do business with the rest of the world. So maybe that's okay, but for everybody else, the cost of being isolated, it just wouldn't make any sense. So you're just going to be overwhelmingly incentivized to kind of come to agreement with everybody else on this system.
Tell me more about why you're overwhelmingly incentivized. What is the incentive?
Well, the incentive is the network effect of being able to interoperate with everybody else in the network. So like the more people using Stellar, the more painful it's going to be if like you're on a different version of Stellar and you can't interoperate with these people.
Right. It's like if you actually want to do anything on a connected network that you're using in the first place to be able to do things, your incentive is to be a part of the network that everybody else is a part of, right?
Yeah, it's like if Comcast were to say like, I mean, so Comcast actually did, at one point, this is very unusual, right? They're a end user ISP, but they went to level 3 right after level 3 signed like a content distribution deal with Netflix and said like, hey, level 3, that's a pretty cool agreement you just signed with Netflix. It would suck if all of our customers started getting like a really bad experience when going to Netflix. So how about you pay us for transit, right? And this is unprecedented, but in the end, like the level 3 decided to like pay up. So it's like, it's not perfect. There's bigger players and they can potentially try to like, leverage their situation, but at the end, like it's gonna work because like, like if really Comcast had like not been able to like reach Netflix, like a lot of people would have left Comcast. A lot of people would also have left Netflix, but it would have been like both sides would have just experienced like a huge amount of pain.
Do you imagine the Stellar network evolving to have those? Because those are pretty well-defined relationships, even financial, like even commercial agreements between entities. Do you and right now the Stellar network obviously has not been around for a super long time, but like, and it is open membership, it's open participation. But as of right now, people are just they run validators, but there's not this sense that they would be negotiating amongst themselves. Do you imagine a world where it becomes more like sort of the way that the internet is?
I think that I don't think it necessarily needs to be as contentious because we don't have the same, because it's expensive to like run a bunch of fiber across the country or whatever, whereas it's not expensive to run a validator. So I think in that sense it's easier. There's other senses in which it's harder in the sense that like with the internet, you can use these, there's more nuance in like how you peer with someone, right? Like there are these things called multi-exit discriminators where like you could, let's say like, we're in London and like I want to, give a packet to somebody in San Francisco, right? Do I carry the packet to San Francisco and then hand it to their ISP, or do I hand it to their ISP here and then they have to do the long haul traffic? So there's things where you can like negotiate like who carries the long haul traffic and things like that. And we don't have that kind of subtlety. Like for us, it's like all or nothing because it's consensus. So literally we have to agree on everything. But the fact that it's cheaper, and also the fact that there's very strong norms around what to do. Like I think that if somebody were to modify their version of Stellar Core to try to like get minor extractable value, like that could be like the tier ones could all get together and like say like, well, we actually don't agree with this, so we're going to exclude you if you do that. So basically, what people do is they run the actual algorithm as it's intended to be run.
Interesting. I feel we have a few minutes left, and I have more questions, but I actually feel like it might be more interesting to hear from the audience. Does anyone have questions? If not, I've got more. But
hello, Katie Ann Wilson on Fifth. So I'm hearing all this and it's fascinating, but I'm also very aware that around the world, central banks are announcing things like Global Layer 1 from Singapore, the Monetary Authority of Singapore. There's also concepts like the unified ledger coming out of the BIS. So I was just wondering, could Stellar provide this global layer 1? Is that the vision?
Yeah, ideally it would. So I'd like to make the case that you can do it. And I think the analogy would be like there were all these sort of like proprietary email systems like before SMTP, the Internet Email Protocol, came out. And then SMTP, it just simplified everything because like you integrate once, and even if you only care about emailing like this one particular person, suddenly now you can email everybody else, and so you get kind of additional value out of it. So I just think it makes a lot of sense. And like part of our job is to convince people that like that's not a scary thing to do. Like you want to do that. Other questions?
I see a hand raised over there in the back.
Hi. So I feel like in a lot of ways, running a validator is kind of like a selfless act because there's some benefit you get, but it's less abstract. I mean, I can run a watcher node and monitor the blockchain and submit transactions to it. So I guess I'm curious on what your perspective is on when it makes sense or what the value is for validators to participate in consensus?
Yeah, so I think like a good analogy would be like, when does it make sense to run a full node for Bitcoin, right? You're not a miner, but like you're like storing the whole ledger and maybe letting people access that. And the reason, one reason you might do it is because you want a copy of the data around. Another reason you might want to do it is for the same reason people like, mirror Linux distributions or whatever, because like, you need it a lot locally, but like you might as well, it's all the whole world benefits if you just kind of make it available. In the case of Stellar, there's this additional benefit that, first of all, if you're an asset issuer, it completely protects you against double redemption attacks, right? So if you issue an asset on a normal blockchain and there's a fork in the blockchain, in the worst case scenario, like if you issued $1 million worth of tokens, you're going to face $2 million worth of redemptions, and people are going to sue you claiming like they were on the real branch and versus the other one. But in Stellar, you can say like, look, these are our validators, and like our validators didn't fork, and if you really cared about, getting paid in our asset, you should have just made sure that that it was final, like on our validators. And then the second reason you might want to do it, so you might also want to do it if like you're a wallet or you have some other important product in the ecosystem, and so you want to assume responsibility for making sure that the network doesn't fork, and then you also get to vote on things like protocol upgrades, right? So, for example, when we were going to go live with Soraban, like it turned out that like some people, because there were some issues in like the first release that we discovered afterwards, SDF wanted to go forward with it, but like other validators were like, no, we think we should take another couple weeks till this is fixed. And okay, so like they win, and it's a very like, we're all working towards the same goal, right? So we didn't even need to like go through the vote and get voted down. We're like, okay, like you're obviously not going to vote for it, so we can put it off a couple weeks and compromise. So there's of course just the ability, the fact that you're voting on it means like we're going to be listening to you, and you're just going to have more clout in the network.
Cool. Governance, I guess.
Yeah.
David, I think that's
one more question, maybe.
All right.
All right.
I'm going to ask a little bit of a more abstract question. So you mentioned MEV in a negative light. What about in the case where you wanted to prioritize transactions in some specific order based on something besides making money? For example, like you wanted to prioritize transactions from humans before bots or something along those lines. What's your view on sort of validators or folks expressing preferences about transaction order, maybe that are non-monetary?
I think that like we should have sort of we should have well-established rules, and people should follow those rules, right? And right now, the way transactions are prioritized is if the block's not full, then you should put in all the transactions you have, and certainly not withhold any to try to get some kind of MEV. And if the block is full, then we run it like a Dutch auction based on the fees. And that seems like a reasonable thing. If it turns out that spam or like bot initiated transactions are like paying higher fees than human users, then I guess we can like, cross that bridge when we come to it. But since the bots issue a lot more transactions, probably they're going to offer lower fees, would be my guess.
I mean, there is some social component, right? Like if all of the people that were running validators on the network got together and agreed outside of the protocol itself that the protocol needed to change, they could, or the
yeah.
Yeah.
And so we could do that. But what I think would be bad is for like different validators to play by different rules and to try to do things to like extract value, because a lot of this like arbitrage stuff, it just ends up like sucking value away from the kind of utility users, and you get value, but that comes out of people's pockets who are actually trying to do like remittance payments or whatever, like kinds of things we actually care about. I hope we don't do that, and I think SCP is a good way to discourage that, basically.
Cool. All right. Thanks, David. It was a
Thank
pleasure.
you.
Thanks for joining me on stage.
Thanks
everybody. That's a wrap for day one.